Hey guys, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to the DIY Metal Router 2 series. So now we're going to be basically talking about continuing going on. I actually got a response from the guy that sells the spindle, so let's go ahead and take a look at that. Looks like it's loading. Okay, we'll let that load and let's go ahead and open up the DIY router. So we're going to go ahead and edit this spindle to get an actual... Oh, I know why it's taking a while to load, because I'm actually uploading a video at the same time. We'll wait for that to load, we'll get back later. So let's go ahead and take a look at the assembly. Sorry about if you hear outside, and my brother's talking in the other room over there, so sorry about that, because it's still hot, extremely hot in here. So let's go ahead and let's cancel this upload here. Cancel upload. Okay, now let's... Okay, here we go. Here we go. So here is the dimensions here. So 240, 30, 65. So we could definitely use every single one of these measurements. So let's go ahead and open up the air-cooled spindle. Let's go ahead and go here. So this is 65 millimeters. That should be correct, 65. And then this first section, because we want this to be as accurate as possible. So this is 240 millimeters. Oh, that's the entire length. So basically it's 240 minus 30 minus 18 minus 48. No, 18 millimeters. Okay, so that's the total length. I mean, that's the length of just the body. Sorry about that. So let's go ahead and go on the bottom here. So that's 7.6 inches. And let's go ahead and go off the top. Create another circle. Now this section here is 40 millimeters. 40 millimeters. And then if we go up top left, let's go ahead and extrude. Hey, what happened? What? Oh. Okay, so this is 18. Oh, and this was 48 millimeters, right? 48, not 40, 48. Oops. 48 millimeters. Why is it doing that? This is 18 millimeters. And then another one on top here. And this is 14 millimeters. Wow, this tiny little guy coming out of that. Okay, so this is 30 minus 13. So this is 30 millimeters minus 13 millimeters. And then we have the final piece, which is the collet at the end of this guy, circle. Okay, so now this is 18 millimeters. And then this is 13 tall. And there is the actual spindle. Okay, so that's the actual spindle there. And then, so this whole thing from end to end should be, should be 240 millimeters. If we go here, should have did this at the beginning. So let's go here, and then here. 240 millimeters. All right, everything's jiving. All right, so what was it before? So 240 millimeters millimeters, 2 inches. 240 millimeters. That's about 9.5 inches long. Okay, and then obviously we need some stuff for the end. So that only leaves us 10 inches almost for the rest of the assembly. Okay, so let's go ahead and this is saved or no. This is not saved yet. So let's go ahead and update this guy. Okay, this guy's updating. Okay, and now it's flipped the wrong way. Oh, that's fine. Okay, so now let's look at our properties. We're at 1,377. I wonder if he has. I wonder if he has the weight of this guy. Package weight's about 7 pounds, so let's go ahead and look here. And that's obviously entire package weight, so this can't be more than 7 pounds. That's in grams now. Let's go ahead and change this back. Properties. It's a little bit more than that, so maybe if I model it as solid aluminum. I want this to be pretty, because again we also have a weight limit on the table. So, and again we don't want to, it'd be nice to have it 200 pounds, but we don't want to go over 200 pounds. So now let's take a look at it. While it's saving, there we go, that's better. Oops. Whatever, it's close enough. That's probably pretty close. It says package weight is 7.72 pounds. So 7.75 pounds. So this is probably actuality pretty close. Probably change it to 70.75. Do they have? They should have 70.75 on here. 70.75. 70.75. Just a little bit more. Yeah, so that's closer. Alright, so I'm just going to go with that for right now. So let's go here. That looks good. Okay. Now what do we have for physical properties here? Alright, so that dropped the mass quite a bit. Oops. 57 divided by 16, so we're at almost 80 pounds. All right, so we need definitely some more mass here. Obviously, these rails we need to fix from last time, so let's go ahead and fix these rails. So these are these rails. So what is going on here? So this is the starting point. Oh, it's mounting off the wrong side. Because this is the end point. Actually, don't do that. Okay, so let's go here. So it's basically it's in the wrong spot to begin with. So let's edit joint. Let's do this. It's actually this hole over here. That's why it's messed up. There we go. Okay. It's still about ½ an inch long. Okay, so let's go here. Okay, so while this is updating, let me check this text message. Alright. Okay, so now we look good. Alright, so let's go ahead and check this one here. So here, missing origin. So we know it's off of this hole in actuality. I believe it's definitely off this hole. Oh! Okay, flip it back. Flip it 180 degrees. And there we go. Also, another thing, obviously we're going to lose some travel here because these blocks are going to hit. So obviously they're going to go up to the block. But the idea is that this guy is just about as big as the block. Okay, let me send a message to this guy. I should probably, so I might send him a message about if he has a super detailed look of the clamp itself, as far as its construction, as far as the you know, all the details stuff. Because there's these, but these kind of protrude outwards, kind of like these. Oops. These guys here. And this has got a really good, yeah, it's got a really good drawings, sort of. Maybe. Okay, so it does look like they're pretty good. So let's go ahead and do a drawing down top. What the heck? Yeah, so this is just a regular clamp. Alright, so... Oh, and it has a bolt hole pattern for the circles. So let's just do down the top and we'll extrude it. We won't do the little slot because that's not necessary. Okay, so they're doing 57. Oh, 65. Okay, so what's 65 in inches? 2.59, so that's this one. Because they have multiple on here. They got 52, 57, 65, 80, and 100. So they have one that says 2.5, so that's it. Okay, 2.5, and then it has a block around it. This block around it. This block is 2.2 inches tall. And then it has an offset here of 0.4 inches. And then the width, and then it has a base, but it never tells me what size the base is. Okay. Oh, it tells me that this is 0.3 millimeters off of this. So if I draw a straight line from here to here, this is 0.3 millimeters. Oops. Yeah, 0.3 inches I meant. Yeah, so that's how it would look like. But it actually, it goes to, it just has this spot, and then it goes to here. And then it has a whole bunch of bolts on top, but they're countersunk. So this is the one. This is the standard one. It's got 3 bolts here. They're countersunk, so that's not really a big issue. What the question is, what does the holes look like on the bottom? Let me see. 52. Okay, so we're gonna have to ask them what the holes look like on the bottom. Pretty much all of these are like that. Okay, 2.5. And then this one looks to be about the 0.4. So yeah, it goes down through here, it stops here, does not protrude out. Okay. And then so this goes down, and then this floor looks to be about the 2.4 here. I mean the 0.4. And this is 2.2 tall. I believe this is off the center, so this should be right. And then this is 5 inches. So this is what? Oh. Yeah, this bottom piece here looks to be about that 0.3. So yeah, let's just do this. Actually, no, let's not do that. So let's call it 5.1 divided by 2. This is about the 0.3, I think. Yeah, that looks kind of okay. That looks about right. Okay, and then the whole thing, so it goes here, 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 and there. And not there. Yeah. This is probably not exactly right, but everything else is right. So, and then this goes this way, 3.1 inches, 3.1 inches. And there is the clamp. So this is a 65 millimeter clamp. So one of the things is I will probably, because I want to bolt it from the top. Oop. So I might drill some bolt holes here and have a plate that I attach to the other one with countersunk holes on it. Or I might find a different bracket. I don't know if I'm too happy with that one. I mean, this one's nicer. This is an 80 millimeter. This is a dateless. I think I even like this one better. I mean, it's not as rigid. But let's see if it's got some. Standby. No measurements. 0 measurements. Come on, Davis. Oh, there you go. So yeah, let's use this guy right now. I just like the layout of this guy better. So it's just kind of, but it has a little bit more protrusion here. I'm not quite sure about that. I wish that this guy was down here somewhere. Oh, this one doesn't have any holes in it. But there's one very, very similar, which is this one, which has holes. So I'll just get that one. I mean, it's basically it looks like almost the exact same. So I'm just going to pretend that they're the same until I see something different. So let's call this op1, option 1. Let's create a new. We're at 20 minutes. Top. Okay, so now let's go ahead and do circle. Oops. 65 millimeter. And then let's go ahead and do offset. Delete that. From the center to the bottom is 43 millimeters. What? There we go. 43 millimeters, it looks like it says. Yeah, that's what it says. Okay. So then, okay, it actually gives me the step height. Okay. Then we're going to do the bottom, which let me get the front view. Looks like it doesn't quite touch the bottom, but let's just assume it touches the bottom. It doesn't actually touch the bottom, it looks like. So this is 125. And it doesn't give us this distance from here to the bottom to the floor. But it does not look like it's touching the floor. It looks like it has about a 1/16 or so before the floor. So let's just give it that, 1/16. Divided by 16. Yeah, maybe even an 1/8, but you get the idea. What was it, 125 divided by 2? Something like that. Oops. Let's change everything in millimeters. Is that what it was? Yep, 125 divided by 2. And it is 15 millimeters tall. 15 millimeters tall. Oops. Tall, and then 125. There it is. And then there's like some blockiness thing. I'm just going to kind of estimate it. It goes from like here down, and then tangent here down. And like here crossed. It's kind of what it looks like. 13, and then this, so this is 20 millimeters. So from here to there, that's 20 millimeters. So we get a little bit better idea there. 0 degree. Okay, so I mean that's gonna. Okay. What? Whatever, man. Okay. Boom, 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 boom. Okay, and then out of like about 45 degrees here. So 180. Oops. 180 divided by 45. Oops. 180 divided by minus 45. There we go. It's about there. Doesn't say exactly, that does look about right, so that's the gap pretty much. And then it says 1 is 16. So let's call this that's about a 16th gap, let's say. So 1 along here, this is about 1 divided by 32. Oops. Oops. 1 divided by 32 inches. Point 0.03125, 0.03125, 0.03125 inches. There we go. I like that. 0.794. Point, where's the point? Wow. You need to really fix this fusion. Hey, Jesus. Alright. So that's the gap. And then we're going to make this kind of perpendicular to the surface there. And then this is however tall it is. No. This is... Oh, it doesn't even say how tall it is. I don't know, that's about 3/8. 0.375. I would say yes. It's about there. Something like that. And then they are... Oh, it gives you the actual... Okay, so it gives you the total gap there. So this gap is actually... We're going to get rid of that for right now. And it does give you the gap. So... Then we have this guy go over. These are 16 millimeters. These are 16 millimeters. What? Oh, those are big. And then they just go right back into it. I mean, there's a fillet there, but we don't need to be that exact on the fillet. Okay, so now they definitely look kind of short. This is 35 millimeters, so I was pretty close on the gap. So that's the actual gap. And obviously this gap goes through. So now it knocked it out of alignment, but that's okay. I mean, again, this is just for kind of viewing. So I'm going to bump this up. This is probably even a ½ inch. I'm not quite sure if I like that. Oops. I'm not quite sure if I do like that, but we'll take a look at it later. Okay, so ooh. And this guy like keeps going. About like that. It's about like that. The whole thing is 79 millimeters. Alright, there it is. Whoa. I see. This actually should be about like that. So this is actually from here to here. I'm going to say it's about 16.035 or something. Yeah. Oops. I'd say that'd be okay. There we go. So that is pretty close. Let's see. Make it a little bigger. It's really, really close. All right, so this is option 2. 65mm clamp. And of course we could always machine our own, so we might even design our own. And this is 18 bucks, as you saw. And we are over time. So next video we're going to go ahead and build the gantry and attach these guys in there, make these 2 materials before we turn it off. Let's just finish these 2. This is pretty much cast. It looks like cast 6061 or some sort of cast aluminum. So let's go ahead and do that. And let's go ahead and do this. And then right before we turn this video off here, call it quits for this video. Whoa. Let's go ahead and look at these properties compared to each other. So properties, this we're talking about. Oh, let's change this. Well, I mean, we could look at grams. Grams is easy too. We just don't have to divide it by 16 now. So 0.883 times 2.2 equals almost 2 pounds. Almost 2 pounds. Quite a bit less. But I'm thinking that this is not, in actuality, it's way thicker than that. So it's probably pretty close to the same. It's probably about the same thickness as this. This one, okay, what's the total length of this? Again, we'll do that next video. Alright, this has been Steven from Legit Tech Tutorials and the Green Engineers. Got a little bit of time. Today's Thursday, 10/11 at 10:30. I'll probably start another video. So we have a little bit more time before I leave on Saturday morning for Hawaii and try to get this guy done. So while we're in Hawaii, I can start ordering a lot of stuff for the Green Engineers for the garage shop. Alright, I'll see you guys in the next video. Thanks for watching. Take it easy. Peace.